today's video, we are going to see section 1.6, which is a very simple section to understand, and the topic is linear approximation and tangent lines. So this talks about the linear approximation of a function if we are given a function. So basically what you have to keep in mind is, suppose if this is the x-axis and this is the y-axis, and you are having the function f to be this green curve sitting here, and suppose if this is an arbitrary point x naught, then this point will be the corresponding ordered pair x naught f of x naught. Okay, and the tangent line of the function f of x at x naught is nothing but the line which passes through x naught f of x naught, the ordered pair x naught f of x naught, and this line passes only through this point of the curve. And f dash of x naught is the slope of the tangent line at x naught. And also we know how to calculate the slope of a line. If x naught here call y naught is equal to f of x naught, you can call y naught is equal to f of x naught. Then if it is so, if you have two lines, 2 points x y and x naught y naught, the corresponding slope of that line will be y minus y naught divided by x minus x naught. And since we know that the slope of the tangent line at x naught is f dash of x naught, you can equate both of them. That is, from here you can understand that f dash of x naught is equal to y minus y naught divided by x minus x naught. So that is an observation you can start with. As you can see, the slope, you usually call it with the letter m, denote it with m, that is m is equal to y minus y naught by x minus x naught, but this is nothing but the slope of the tangent line which is f dash of x naught, which we had seen before in the earlier sections. So by equating, you get f dash of x naught is equal to f of x minus f of x naught divided by x minus x naught, since y is f of x and y naught is f of x naught. We denote it like that. So cross multiplying, you get f of x minus f of x naught is equal to f dash of x naught into x minus x naught, and take the rest of the terms to the right side, you get f of x is equal to f of x naught plus f dash of x naught into x minus x naught. So that is f of x being y, you get y is equal to f of x naught plus f dash x naught into x minus x naught, which is the equation of the tangent line at x is equal to x naught. So the same is seen here in the rectangular box. This is a very important equation. Yes, and this is the equation of the tangent line. So the next questions will be to find the equation of the tangent lines. The first question is, you are given a function or graph y which is equal to f of x, which is root x plus 1 by 2 into x plus 1. You have to find the equation of the tangent line at x is equal to 1. So for that, what we are given y is equal to f of x, which is equal to root x plus 1 by 2 into x plus 1. You have to calculate the tangent line at x is equal to 1, right? So first think about the equation. This is the equation, y is equal to f of x naught plus f dash x naught into x minus x naught, and given that x naught here is 1. So you have here x naught is 1. Okay, so you have to find f dash of x naught, that is here you have to find f dash of 1. For that, first you have to find f dash of x. F dash of x is equal to d by dx of the function here. So first you have to apply d by dx on this. D by dx of two functions will be equal to d by dx of the first function plus d by dx of the second function. So you get d by dx of root x, which is equal to 1 by 2 root x, d by dx of 1 by 2 into x plus 1, which is equal to minus 1 by 2 into x plus 1 the whole square into the derivative of x plus 1, which is 1. So in total you get 1 by 2 root x minus 1 by 2 into x plus 1 the whole square. And substitute for 1, you get f dash of 1 is equal to 1. You get 1 by 2 minus 1 by 8. Here you have 2, here you have 1. So 2 square will be 2 here. So you have 4 here. 2 into 4 will be 8. So 1 by 2 minus 1 by 8, you get it to be 3 by 8. And also you need f of x naught. So you need f of 1. F of 1 is equal to, you substitute instead of x 1. So you have root 1, which is 1. 1 by 2 into 1 plus 1, that will be 4. 1 plus 1 by 4, you will have 5 by 4. So the equation of the tangent line is, when you have a question, you write what the equation of the tangent line is. This equation you have to write it first and then substitute for whatever which is given here. So you have y is equal to f of 1 plus f dash of 1 into x minus 1. That is equal to, we have calculated f of 1 and f dash of 1. You get 5 by 4 plus 3 by 8 into x minus 1. And you can rearrange it. Take the LCM. 4 and 8. The LCM will be 8. How to find LCM? Yes, you have 4 here, 8 here. Then the common factor here will be 4. So you have 1 here. Then you have when you divide 8 by 4, you get 2. So 4 into 2, that will be the LCM. LCM will be 8. 8, and then so here it is 4. So in order to make it 8, you have to multiply it with 2. So here also multiply it with 2. 5 into 2. So you get 10 here. 10 plus 3 into x minus 1. So in total you get y is equal to this. So cross multiply with this 8. So you get 8y is equal to you have here you have 10 plus 3x minus 3 by 8. By 8. So you get 8y is equal to 3x plus 7. So that is the answer for the A part of the question number 1. The second question is same. We have to find the equation of the tangent line. You are given the function f of x is equal to 2x plus 1 divided by 3x plus 1. You have to find at the point x is equal to 1. So here also x naught is nothing but x naught is 1. So you have the function f of x is equal to, so this is b, f of x is equal to 2x plus 1 by 3x plus 1. So you can calculate f of 1, you get 3 by 4. Calculate f dash of x using the quotient rule. So you have derivative of the numerator into denominator minus derivative of the denominator into numerator divided by denominator the whole square. And then you find f dash of 1. You substitute instead of x 1. And there you get it to be minus 1 by 16. So in total, equation of the tangent line is y is equal to f of 1 plus f dash of 1 into x minus 1. So here you have f of 1 to be 3 by 4 and f dash of 1 to be minus 1 by 16. So finally you get y is equal to 3 by 4 minus x by 16 plus 1 by 16. Take the LCM. LCM is 16. Then simplify. You get it to be minus 13 by minus 13 minus 6 divided by 6. 13 minus x divided by 16. Then cross multiplying, you get the equation to be 16y is equal to 13 minus x. So this is the answer for the B part of question number 1. And example 2 also you have to find a little tricky question. Where does the line tangent to y is equal to root x at x is equal to 2 cross the x-axis? So geometrically saying, suppose if y is equal to root x, maybe it is some curve like this, 0. So x is equal to 2 is the line x is equal to 2. Suppose x is equal to 2 here, and the x-axis is nothing but this one. So maybe so the question is, if you have a function, see how to plot the function. It is necessary to, in order to understand, say if you have a function f of x to be equal to root x, so 0 0 will be a point. When we take 1, that will be 1. Also -1. Then if you take 2, the answer will be comma plus or minus root 2. So here you don't have any domain. So you can have root 2 maybe some here, and you have okay, for 1 you have 1 comma plus or minus 1. So this is 1 plus or minus 1. And when you have 3, you have plus or minus root 3. So like this. So it is something like of a curve like this. Okay, this is y is equal to root x. You can plot it and find out. And also x is equal to, x-axis is nothing but this axis, and this is having the equation y is equal to 0. Right. Okay, so this dy by dx is considered. Dy by dx is equal to d by dx of root x, which is equal to 1 by 2 root x. Okay, and at x is equal to 2, we calculate dy by dx, you get to be 1 by 2 root x. Okay, now what is the equation of the line? Equation of the line is y is equal to, instead of f of x, we are just using y. Y is equal to y of 2 plus y dash of 2 into x minus 1. Okay, so y of 2, you calculate it to be root 2, y dash of 2 will be 1 by 2 root 2, we calculated it here, and into x minus 2. Then you rearrange, and finally you get the equation to be this. And we know that equation of x-axis is y is equal to 0. We are asked when they will cross. When the functions, when the tangent line and the x-axis will cross. So that means we have to equate both of them. So here you know y is equal to this term here, and also we know x-axis is equal to y is equal to 0. So we equate both of them. Then you get root 2 plus 1 by 2 root 2 into x minus 2 is equal to 0. Then you simplify it, and finally what you get is x is equal to minus 2. So when x is equal to minus 2, our condition is satisfied. That is when the line tangent to this function will cross the x-axis. Okay, so the next one is linear approximation. For that, we know that the difference quotient delta y by delta x is equal to f of x naught plus delta x minus f of x naught divided by delta x. So limit, also we know that limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0, the term sitting here, which is nothing but denoted as f dash of x naught. We know all these things. And just consider this difference quotient delta y by delta x minus f dash of x naught. So we are just simply calculating that. So you get f of x naught plus delta x minus f of x naught divided by delta x minus f dash of x naught. Okay, and assume that this term is a value d. Okay, say we are assuming it. Say means we are assuming. Now take the LCM of this part. So you get delta x is taken as the LCM. You have f of x naught plus delta x minus f of x naught, and this f dash of x naught should be multiplied with the delta x. Okay, that is equal to d. Then cross multiply, you get this, and rearranging you get f of x naught plus delta x is equal to f of x naught plus delta x into f dash of x naught plus d into delta x. Okay, suppose if this x naught plus delta x is equal to x, you can take it like that. Then delta x will be x minus x naught, rearranging this. So you substitute them in this, you get f of x is equal to f of x naught plus f dash of x naught. Instead of this delta, you are substituting x minus x naught, and instead of this delta, you keep it like that. Okay, you need not change this delta. Okay, and as this delta x is tending to 0, we know that a quantity into delta x will also tend to 0. It is a very small quantity. So we are trying to approximate this function by removing this term here. We are removing this. So when we are removing this much quantity will be approximately equal to f of x. Okay, f of x is approximately equal. This is the sign for double tilde. This is the sign for approximately equal to. So f of x is approximately equal to f of x naught plus f dash of x naught into x minus x naught. Also you can write the same as f dash of f of x naught plus delta x is approximately equal to, it is the same, f of x naught plus f dash of x naught into delta x. You can write it like this or like this. So this is called the linear approximation of f at x naught. So now we are going to work along this section on linear approximation. You can see in the figure that the function, this is a curve, this is the function y is equal to f of x. The linear approximation at x naught is shown there. That means you have the difference between f of x and its linear approximation sitting here. Okay, this is the line is nothing but the linear approximation of the function sitting here at x naught, which is nothing but the tangent line. Yes. Okay, this linear approximation is also called as first order approximation. Please note that too. Okay. Now we'll deal with example 3. Example 3 says that we have to find the linear approximation of x naught plus delta x the whole square, and we have to claim that the linear approximation is the guy sitting here. Okay, so we are assuming that since you know that this is something square, we are assuming that f of x is equal to x naught x square. Okay, that means you know f dash of x is equal to 2x. Then f of x naught plus delta x, we have to assume this and you get f of x naught plus delta x is equal to x naught plus delta x the whole square. So also f of x naught plus delta x is equal to f of x naught plus f dash of x naught into delta x. How? By linear approximation we just said. Linear approximation we just defined now. So you can substitute instead of f of x naught you have x naught square, f dash of x naught you have 2x naught into delta x. So you are arriving at the final answer. And for B, we are asked to calculate the approximate value of 1.03 the whole square and to compare with the actual value. And we are asked to do the same thing for 1.00003 the whole square and 1.0000003 the whole square. So for that, consider here also the function is f of x is equal to x square. We have been given, we have to take the approximate value we have to find is 1.03. So we have to take x naught is equal to 1 and delta x is equal to 0.03. So you get x naught plus delta x is equal to 1 plus 0.03, which is equal to 1.03. and then since f of x is equal to x square, f of x naught plus delta x is equal to f of 1.03, which is equal to 1.03 the whole square. Keep it there. Okay. And by linear approximation, we know that f of x naught plus delta x is equal to x naught squared plus 2x naught into delta x. We found it from A part. Okay, so you get that is equal to 1 square plus 2 into 1 into 0.03. So finally you get that to be 1.06. Now using your calculators, you can find 1.03 the whole square. Then you are going to get this value. Using calculator, you can find it. Calculator. So you understand that this one is actually an approximation of this value, right? So also we are asked to find the square of 1.003. So here also you take x naught is equal to 1, take delta x is equal to 0.0003. Then in the same manner find f of x naught plus delta x, you get 1.0003 the whole square. Using linear approximation equation, you get from this, we proved in A, you get this, substitute for the values and you get this. And using calculator, you get the original value to be this. So you get that this value is an approximation of the original value. And also the same manner you find for x naught is equal to 1 and delta x is equal to 0.000003, and end up with the question. Here the linear approximation is again given a tabular form, which we already said. This is just a reminder about what we said. Okay, so example 4 is a question which is asking us to calculate the approximate value for the following quantities using linear approximation. The point given is x naught is equal to 9 and we are asked to compare with the values on our calculator. Okay, the first question is root 9.02. So what is the logic? You have to take f of x is equal to root x, right? Then you get f dash of x is equal to 1 by 2 root x, and you have to take the value x naught is equal to 9. Okay, how to take the values here? And this is a linear approximation. The linear approximation equation, which is given earlier. So here you have to take x naught is equal to 9. So if you take x naught is equal to 9, then delta x is equal to 0.2. Then when you add them up, you get 9.02. Now, so root of 9.02 is approximately equal to the linear approximation equation. That is root 9 plus 1 by 2 root 9 into 0.02. It's just like this. We know f of x naught plus delta x is approximately equal to f of x naught plus f dash of x naught into delta x. So you just substitute for them. You know, you have taken f of x to be root x. Then substitute whatever is required, and you know that x naught is equal to 9. Just that. And delta x is equal to 0.02. And for B part, you take x naught to be 9, then delta x to be 1, because the total you have to get 10, right? And then the same. In C part, you take you have x naught to be 9, so you have to get 8.89, right? So you have to take delta x to be minus 0.18. Then you get 9 minus 0.08 will be 8.82, and then you substitute in the linear approximation equation to get the values. And also remember to find the values in the calculator and compare with what we obtained. And the D part is you have to calculate value of root 8. So you have x naught to be 9, then take delta x to be minus 1 and then calculate. and then compare the values in the calculator. Example 5, so that ends that question. Example 5, we have to calculate linear approximation to the area of a square whose side is 2.01. So, and we are asked to draw a geometrical figure obtained from a square of side 2 whose area is exactly that given by the linear approximation. Okay, so say you are seeing the figure here. So this, if this is 2.01, up till here is 2. Okay, up till here is 2. So you can understand that this much will be the area of the square having side 2, and you are left with 3 sections, one, this section and this section. That will be the difference of the areas. So suppose you know that area of a square is the side square. So if r is the length of the square, you can define a is equal to f of r, which is equal to r square. We have to find the linear approximation near r naught is equal to 2. So fix r naught is equal to 2. So we have f of r naught plus delta r to be equal to f of r naught plus f dash of r naught into r minus r naught. We are just replacing r instead of x in the linear approximation definition. This is the linear approximation. So instead of f of r naught, you have r naught square, because why? F of r is defined as r square, and f dash of r naught is nothing but f dash of r is 2r. So f dash of r naught will be 2r naught into r minus r naught. And when you simplify, you get r naught is taken to be 2. R naught is 2. So you get this to be equal to 4 plus 4 into r minus r naught. That is what is written here. Now r minus r naught. R is 2.01 minus 2. So you get that to be 0.01. So this is actually the small delta we have talked about. Not r minus r naught is equal to 0.01. Fine. Now what you have to do is find f of r naught plus delta r. So that is equal to 4 plus 4 into 0.01. So you get it to be 4.04. So that's how you end up with the linear approximation of this figure. So you can say that the square of the side 2.01 differs only by a small shaded square in the corner whose area is 0.01 the whole square, which is equal to 0.0001. Now to calculate example 6, here you are given a function. So with the logic of the given value, you are defining the function f of x to be equal to 2 by root x plus x square. Okay. We are asked to calculate the approximate value. Okay. Suppose if we take 1 to be x naught and delta x to be minus 0.01. If we take like that, we know f of 1 minus 0.01 will be f of 1 minus f dash of 1 into 0.01. Okay, find f of 1. F of 1 will be 2 by 1 plus 1. That will be 1. F of 1 will be 1. And find f dash of x by the quotient rule. You will get, when you simplify, you get the value sitting here. Now find f dash of 1. Substitute x for 1 and you get that to be equal to minus pi by 4. and in total you get f of 1 minus 0.01 will be approximately equal to 1 plus 5 by 4 into 0.01, which is equal to the value sitting here, and you can compare it with the value we get from the calculator, which is the guy sitting here. So here what you did is actually define f of x is equal to 2 by root x plus x square. We defined it like that. Then what we did is we found out f of 0.99 by thinking that f of 0.99 is 1 minus 0.01, and then use the linear approximation as we just said. And then we are left with the exercise section of this part, and you have to solve till question number 40. You can leave the questions in between. Find all the questions from 1 to 24, and then find 29 to 40. Solve these questions 1 to 24 and 29 to 40. Solve. So thank you for watching out. See you in the next video lecture.